Hi there, my name's Andy Young and I'm one of the automotive lecturers down at Unitec in Auckland, New Zealand. Now this is a continuation of a previous video that I've done on TPS testing, that's throttle position sensor testing, and we have here the old TPS that was in that video off the Chinese, what was it, CF Moto 650TK. Brand new bike, still in the crate, was damaged at the docks. And based on those findings, before we had a workshop manual for the bike, because being Chinese pretty hard to get hold of, I did order a new part, and turns out the part has been superseded. Yeah, there's an old part number on here and a new part number, and this unit is slightly different, and we'll see the difference once it's out of the packaging. But it also mentioned in the packaging that the unit is very easily damaged due to shock, which would obviously give us an indication why the old one may have got damaged when the crate was dropped off the forklift down at the docks. Now, we did some tests on the old TPS. The problem with the bike is it's massively over-fueling. It's running really, really rich all the time. The output voltage of the old TPS at idle, as you saw in the old video, is around about 3.5 volts at idle. That's throttle closed, bike just ticking over. In actual fact, now that we have, believe it or not, the actual proper workshop manual, both in paper and digital format, turns out that 3.5 volts output is basically the voltage that it should be at when the throttle's fully open. So the ECU is getting a signal saying, hey, throttle fully open, when in actual fact the throttle is fully closed. And the ECU is delivering sufficient fuel into the engine based on the fact the throttle is fully open, when in fact it's fully closed. So there's a tiny amount of air going in the engine instead of lots of air, same amount of fuel as if it was fully open, which means we're going to run incredibly rich. Hey presto, I reckon we found the problem. TPS units are fundamentally flawed. They do have many problems, and these old ones rely on a variable resistor inside a tract, basically a little finger runs across which changes the resistance. And unfortunately, because they have an input off the throttle body, the throttle shaft goes into there, it turns that there is a possibility that moisture and dirt can get in, because they're not very well sealed, to get in through there, and that of course causes corrosion and stuff on that tract and causes problems with the resistance values. That isn't the problem on this occasion. I reckon this has been damaged due to shock. So we've got the old one, we've got the new one now in the packaging. We'll get it pulled out, we'll set up the rig, and we'll take readings for the old one and readings for the new one. And I'll put on the screen for you, somewhere, one side, the actual specifications, both that'll be voltage output at idle, voltage output at full throttle, and of course some resistance values as well, just to be on the safe side. Okay, let's make a start. Try and keep this short for you. Okay, so everything's set up as before. We've got the 3 pins on the TPS. Pin number 3 is your earth. Pin number 1 is our 5 volt supply, and the center pin is our output signal voltage, which goes to the ECU. So I'll turn on the multimeters. We've got a voltmeter to allow us to accurately control the output voltage of the actual power supply, and we're on 5.01 volts, which is near as damn it bang on. And this is our output signal voltage. So as you can see, the TPS isn't being actuated at the moment. It's in the fully anti-clockwise position, and we're getting 3.5 volts at idle. Now if I open up that TPS just as if the throttle was opening on the bike, turn that round, you can see that what we're gonna get near as damn it, well, 4.8 volts, 4.7 volts, which is way above specification. So when that TPS is on the bike, it's going to be giving out a signal as if the throttle was fully open when it's at the idle position. Big fail. In actual fact, you can see it's changed again now. So there's definitely something very wrong with it. We've got 3.1 volts at idle on this occasion. 3.3, 3.1. So yeah, there's a lot of irregularities. TPS sensors are supposed to be extremely accurate. This one's bouncing around all over the place. No wonder the bike was a bit upset. Okay, so we've seen with the old TPS unit, at idle position we're getting about 3.5 volts. At fully open throttle position we're getting about 4.8. The specification, what was it? Idle, it should be between 0.4 and 0.7 of a volt. We're getting 3.5 volts. And at full throttle it should be between 2.9 and 3.4. We're getting 4.8. Again, it's way out of spec. So let's grab the new one, pull it out of the packaging. There it goes. And let's not drop it, and see how that one works. Now this one appears, let's turn that down, it's actually very different. As you can see here, look. We've got the old one, which is made by, I don't know, some company in Italy, look. Okay. And we've got this one here, which is made by Delotto. I think they make carburetors as well, look. Okay, this one's a lot better sealed, and more to the point, which is really important to me, is on the old one there was no adjustment. On the new one we've got a slot, which means we can actually dial in and calibrate this TPS on the bike. This one couldn't be calibrated. This one was a bolt on, hopefully it works kind of thing. This one we can actually rotate in relation to the spindle, butterfly spindle, and we can actually calibrate this. That's a big bonus. We can make things better. Other than that, we've still got the 3 pins, and they've also still labelled up 321, so I'm assuming that they all still relate to the same pins. Yeah, I reckon they will. Okay, I'll wire this one up and we'll see what we get. Right, so new unit. 3 is earth, green is earth. We'll stick that in there. Really important to keep these pins apart. We don't want the connectors touching. Cause a bit of a short circuit if that happens. Right, turn on the power supply again. So a 5 point, oh, bang on 5 volts, look at that. Okay, and looking at this, okay, we've got essentially 0 volts output at this point in time. Right, if I very carefully insert the screwdriver, we should be able to rotate that. There you go, look, okay. So we're starting off now at 0 volts, and we can dial that up very slowly, heading up towards full throttle. Now at maximum throttle it should be between 2.9 and 3.4. Now, it may go higher than that, but we've got some adjustment to play with on this one. Okay, so we're able to. I think we're going to get full range. 4.2, 4.3, 4, 5, 6. Yeah. Okay, I'm not going to go any further. There we go. 5 volts. All right. So when we put this on the bike, and I'll cover that in the video. That'll be another video installing a TPS. At idle, we should get somewhere around, well, between 0.4 and 0.7. So that's the voltage that the ECU wants to see, or should be seeing, when the throttle's closed at idle. Wow, that was completely different. On the old one we got 3.5 volt start point, 4.8 volt fully open finish point. On the new one, starts off essentially at 0 volts, and we can take it right up to 5. So we've got full range on this one, and of course because of the slot at the top we've got some adjustment to calibrate this on the bike. So things are looking really, really good. I bet CF Moto really hope that they hadn't actually fitted these, because I think they're having a lot of problems with them by the sounds of it. Okay, so that brings us to the end of the video. That's how you test a TPS. And I just wanted to do a second video showing you the difference in the readings between the original TPS and the new one. A world apart. No wonder that ECU was doing weird stuff. If you found that the TPS was giving out the correct voltage, doing a bench test, then other things that you want to do is check the wiring between the ECU and the sensor itself. Don't forget, these sensors run at a dedicated 5 volt DC supply which comes from the ECU itself, so you should be checking that. Is it 5 volts? If it's not within spec, and there will be a spec. I think on this one it's 4.75 volts to 5.25 volts is what's acceptable. If that's not within the spec, then you should check your battery, make sure it's fully charged. If it is fully charged, then check the wiring, check the resistance of your wiring between your ECU and the sensor itself. If the sensor output voltage is correct, but at the pin on the ECU you're getting a different voltage going in, the signal wire in, then again check the wire that goes between the sensor and the ECU. You might find a break or a short down to ground on there. What I've also noticed on some of these fuel injected bikes is the 3 AC output wires from the generator, the stator, the 3 stator winding wires. They actually run through the loom to the regulator rectifier, which is a separate unit on a motorcycle normally, and they can, if they're not shielded correctly, they can induce voltage into sensor wires. So even though you're getting the right voltage out at the sensor end, by the time that voltage gets to the ECU, it's had an additional voltage induced into it due to the magnetic field created by that AC, that very high 90 to 105 volts AC that's running down each of those 3 wires from the stator. So again, you can always break into the loom, pull those wires apart, separate them, put some foil around them, put some like sort of gauze sheathing, some metal gauze sheathing over them. That's how it should be if they're going to run together, and that protects that really accurate voltage that's in those sensor wires. Okay, it was going to be a short video. It is a short video. That's the end of it. I hope you found that helpful. It is important to test new components when they arrive before you put them on the vehicle. You've already tested the old ones, so you know how to do it. It's pretty easy. And it's really good to compare the old results with the new results, and to also make sure that the new component that you're fitting is actually within specification, because they're not always. And with this kind of stuff, which is very sensitive to being dropped, I was really dubious that this might still be faulty. It might have been made faulty in transit. Turns out it's all good. I think this new brand, this Delauto brand, is probably a lot more resistant to impact damage. Maybe that's why they've changed to it. Okay, well, my name is Andy Young. I'm one of the automotive lecturers down at Unitec in Auckland, New Zealand. I hope you found this video interesting. If you did, then why not subscribe to the channel? Just click subscribe and then you'll get notifications whenever any new videos go up on the channel. And there's usually 4 or 5 a week. It's pretty busy at the moment down here doing these videos. If you have any questions or comments, then again, just leave them down the bottom and I will promise to get back to you as soon as I can. And I'll do my best to help. Okay, thanks for watching. Cheers, over and out.